Hi guys, in this video we're going to talk about if a pair of linear functions are parallel to each other, perpendicular to each other, or neither of the two, using graphs. First we're going to talk about the anatomy of a linear function. So linear functions come in two forms. For this video we're going to function on the slope-intercept form. Sometimes linear functions come in standard form, then we have to convert them. And the reason why we have to convert them is because the intercept form is very graphable. So, for starters, we look at this M here. M actually stands for mountain. And this is the slope of which the line will go up or down the graph, or climb up and down the graph. Then this is the y-intercept. So this is where the line will cross the y-axis. And typically what we do is we actually read these from right to left as opposed to left to right. And there's a lot of history behind that and why that happens. But for right now, we just need to understand that we're going to read this from right to left. Okay, let's take a look at the first example. Okay, so we're going to start with this example with our two lines in y-intercept form. This is our slope and y-intercept for this line. I know this is our slope because this fraction is closest to the x variable. Here is our slope for this line, and this is our y. And just like functions in the previous video I've done on solving quadratics, x is the input and y is the output. So now what I want to do is I want to graph this. Recall in the last slide that I suggested to read these equations from right to left. So I am going to start by graphing the y-intercept, which is 1. So that means this line will cross the y-axis at 1 right there. Now, the slope. There is actually quite a bit of debate on how to teach counting the slope. The way I count the slope is I always move to the right. Unless, for some reason, on my graph there isn't enough room. So, I always count to the right, and then the negative dictates if I'm going to count up or down. The other way you could do it is you could always count up or down, which is up to you. Then you can change if that's a negative to count right or left. Better be careful when you do these things because remember, down and to the left is a double negative. So, in this example, I am going to count down 4 and right 3. Because I don't know if the cursor is going to show up in the video, I'm actually putting my little dots here. So that's 1, 2, 3, 4, then 1, 2, 3. So that's the way I count it. Now what I'm going to do is with the straight edge is draw the line. There is no computer magic happening here. I am legitimately using a straight edge to draw this, as you can see, because my line did not come out perfectly straight. But that is graphed. So now let's do the next one. I'm going to follow the same steps. Let me just erase my counting lines here to make my life a little bit easier. So I'm going to start at -5. And if you notice, right, I do kind of run out of room here. So this would be one of those situations. If this was a negative slope and I was going down, I would have to count up and to the left. But thankfully it's positive. So I'm going to count up 3. 1, 2, 3. And to the right 4. 1, 2, 3, 4. And now I'm going to draw that line with a straight edge the best that I can. Okay. Now, if you look at these, right, sometimes it's actually very hard to see, but if you look at these, you'll see that I'm making a right angle here. So, that means that these lines are perpendicular. Sometimes it's very difficult to tell if the lines are very close together. There is also a pattern here for you to take this time to with the slopes. So pay close attention to what's going on there with these slopes and see if you could start to see why these lines are coming out to be perpendicular. Compare this to the other examples. In this example, the lines are in standard form. So what we have to do is we have to convert them to slope-intercept form. This is an important skill set that students often struggle with and really need to take their time because it involves the same inverse operations as solving equations. But what I want to do here is I want to get this y by itself as opposed to getting the x by itself. So what I'm going to do is I'm going to underline the y and move everything away from that. To do that, I have to move the farthest thing away from the y. So I am going to subtract this 3x. Now, these terms do not go together. So that means carrying down is the negative 3x minus 4. Then what I need to do is this is multiplication, so I'm going to undo that multiplication by dividing by 2. A little algebra rule here, or arithmetic rule, is really what I should be saying, is that you could separate that this way. You don't have to follow through on this step, but I just want you to visually see what's going on. So now we want this to remain a fraction. In fact, very rarely do we want something to not be a fraction. So, I am going to leave this that way. Now I'm going to do the next one. Okay, same thing here. So I'm going to subtract the 3x. Both sides. These will not go together. Then I'm going to divide the 2 to both of these terms. So I am going to end up with negative 3 over 2x minus 3. And now it's time to graph them. Okay, so I'm going to start at negative 2, which is down here. Then I'm going to count down 3. 1, 2, 3, and write 2. Again, think about how that pattern, there's a number of ways to do that. And then I'm going to graph this line with my straight edge that looks like it was abused. But I think it's just the screen is that sensitive. So there's that. Alright, let's graph the next one. Graph the two functions. So I'm going to start at negative 2. I want to take a second and show you what I mean about the different ways to count a slope. So I could count down 3, 1, 2, 3, which is negative, then right 2, which is positive. So down 3, negative, right 2, positive. I could also count up 3, 1, 2, 3, which is positive, then left 2, 1, 2, which is negative. And that makes the same line. So when I line up my straight edge, you'll see my points will all line up and stay consistent. Okay, let's graph the next. Okay, so now I'm going to count negative 3, start negative 3, and I will do this again. So I'm going to count down 3, 1, 2, 3, then right 2. You don't have to make all these little dots on your graph. I'm just doing it to help make sure you can see what I'm doing. Again, if I choose to and I got to make another point, I could count up 1, 2, 3, then left 2, 1, 2. Now if you notice, I always have to have the top of the bottom be negative or positive. I cannot make a double negative, because remember, a negative divided by a negative makes a positive. So if you don't have the room, you could always count down and left and create a positive line. Now these two lines are parallel. Alright, last example. Okay, so I'm hoping by now you're starting to see a pattern with the two slopes. If you look at the last two examples. Let's do this last example and see what we get here. Just like before, I have to convert these to standard form. So I'm following the same exact algorithm as I did before. And I'm going to divide both sides. So this is equals -3 over 2x plus 1. Alright, let's do the other one. Okay, so I fast forwarded through this a little bit so that we could save some time. I'm sure you've enjoyed watching me solve this 4 times now. So here's something that's going on. This fraction can be reduced. So what that means is that I could divide both of these by 2. -8 is divisible by 2 and 4 is divisible by 2. All reducing is dividing the top and the bottom by a number that they're both divisible by, and in this case 2. I don't necessarily have to reduce, but in fact, what am I saying here? So let's take a look at what I just did. So that's -4 and 2. And then x minus 6. So I just made a mistake and I could cut it out, but I'm going to keep it here. So now I realize I could reduce even more. So I didn't catch that. And here's a great example of how I make mistakes too. So you can reduce twice. So I ended up reducing twice by 2. Alright, that's a little messy there. Let me see if I can get rid of the green stuff. Okay, so now that that's over, I don't actually have to reduce when we're graphing lines. And I'm going to show you why. In fact, this mistake provides us a great opportunity. So let me quickly graph the first one. And now I'm going to graph the second one. And what I'm going to do is I'm going to use this last one here. But in a second I'll show you why that wasn't necessary. So in this case, I'm at the bottom of the graph. You have two choices here. You could extend the graph, which is not practical, by grabbing a ruler and drawing a bunch of boxes. I would never recommend that. Or what you could do in this case is I can count up to left 1, which creates a negative line. Alright, let me graph that. Okay, in this case, the two lines are neither parallel or perpendicular. If you look at the graph, the points are getting closer together. In other words, at some point, if I were to extend this, I don't know if I'll make it on the screen. I will try to do it. Maybe that's a little bit more obvious now. Alright, so we could see that these lines are going to meet at some point. They are neither perpendicular or parallel because in this example we saw a right angle. In this example we saw that they stayed equal distance from each other. And in this example we could see that they're going to meet. Alright, one more thing I want to show you. So, watch what happens if I don't reduce. So I'm going to start at -6 here. And I'm going to count this line here. I'm going to count up 1, 2, 3, 4, 1, 2. See the way I still landed on that line? Let's do it one more time. I'm going to graph this one. This time I'll go up 8, left 4. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4. Alright, my straight edge was fighting me there. But if you notice, they're all on the same line. So couple of things I'd like to show you. One is, this is why reducing fractions always creates an equivalent fraction, because the slope stays the same. In other words, nothing's physically changing. You're just counting less of the same thing. A second thing is, I want you to see, and this is just an opportunity, that reducing fractions doesn't have to happen once. It can happen multiple times. So as you gain more experience, you make those mistakes less and less, but every once in a while, like myself, you make that mistake. But a mistake's always an opportunity to learn something. Alright guys, I hope you guys have found this video to be helpful.